We are now going to take a different approach and have our mobile robot ask the conveyor where it needs to go to pick up parts. To do that, we are going to use a transport protocol behavior, which allows you to set the pickup or delivery information for a component. To get started, I'll select the mobile robot in the 3D world. I'll now access its Python script that we have been working on. We do not need these lines of code anymore in the onRun event, so I will delete them. So in our script, we are suspending the onRun event until we get a signal from the conveyor. And once we get that signal, let's get the part at the end of the conveyor's path. I'll write part equals conveyor.child components, and I'll get the last item in the list, so an index of -1. From there, I'm going to use the part or component object to call this method, getTransportInfo. We don't want the transportation information from the part, we want it from its parent, which is the conveyor. So I'll say part.parent. So the part is moving along the conveyor's path, so the part will tell its parent to give our mobile robot that information of where it can be picked up. So if we compile the code and run our simulation, here comes the cylinder. And then you can see in the output panel we get printed this tuple here of information. So the first element is defining whether or not the part can be picked up or not, if it's available, not available, or kind of idle situation or buffering. The next two arguments or information indicate, what is the component in the transportation information. The next element is the container information, so what part or where are you located, and are you contained in something? So are you contained in a pallet, for example, or on the top of the conveyor? The last piece of information is the location that you want to give. So by default right now, every component will have this set of information. So 0 for not available, its component container will be none, and this matrix object actually is just a brand new matrix, it's empty. It'll give you 0, 0, 0 for its position vector coordinates. Let's reset, and to make this information more useful, let's actually change what information is given to our mobile robot. To do that, I'll select the conveyor, and now let's go to our behaviors drop-down menu here, and then under miscellaneous, I'll click transport protocol to add that behavior. Let's now add a Python script and make our text bigger. We don't need the onSignal or onRun event, so we can delete these. Let's get the component object, and remember, we're now working in a script that's in the conveyor, not the mobile robot. So comp equals getComponent. Let's get the conveyor's path. I'll write path equals comp.getBehavior. The name of the path in the component is main-path. Let's also get our pickup location, the frame located here in our conveyor. So I'll say frame equals comp.getFeature. We're basically doing what we were doing in earlier videos. So pick up location, and let's get the frame's position in world coordinates. So I'll say point or location equals the component's world position matrix times the frame's node position matrix. Make the script editor a bit bigger for you. There we go. And now the only thing we're doing new is with the transport protocol behavior. So I'll write TP equals comp.getBehavior. The name of the behavior is transport protocol by default. And let's print out that variable. So print TP. Compile the code. And in the output panel, you can see that a transport protocol is a type of VC transport object. So to learn more about this object, let's go to our API reference. And then the contents, let's go to the VC transport topic. And here you can find information about that protocol. You have an event, so when somebody requests the transportation information, this event will be triggered. And it will also give you the caller of the request. Then you have this method called setTargetInfo, and this will allow you to set the information that was printed here earlier for where we want to pick up the part. And if we go back to VC component in our API reference, then go to methods, scroll down. Here you can find more information about the get transport info method. Let's now go back to our script and use that method and event for our protocol. So I'll write tp.on transport info equals, let's call it order. So for our order function, we'll get the caller, but we really don't need to worry about that now because we know our part is actually calling the transportation information from the conveyor. So what we want to do is set the data that's given to the vehicle. So the first argument has to be our transportation protocol to call that method of set target info. And what do we want to do? We want to say that the conveyor and its parts are available. So we'll give a constant here called vc_available. And then you could give the part or the component, whatever you want to give. So we'll actually give the conveyor as the object in our second argument here, because in some cases you may want to work with the component to adjust the pickup location. So it can be helpful to have this component object. Then we'll give the container, in this case it's the path, and then we'll give the location we want the vehicle to go to, which is that frame feature in the component in world coordinates. I'll compile the code, and now if we run our simulation and pay attention to the output panel, we should get some new information. So here comes the part. And yep, you can see in the output panel, we got the first item is a 1, so we know something is available. We got a component object. We got a container object, in this case a path, and a position matrix. So let's use that information in our mobile robot script. I'll reset. We don't need the straight conveyor template script anymore, so we can just close it out. Go back to your mobile robot script, and instead of printing the data, let's get it. So let's say data equals part.get transportation information, or get transport info. And then we want the location. So let's say target equals data, and it's the last argument or item in that data list or tuple. It's also, you could also give an index of 3 if you want. And from there we actually want to get the position matrix position vector. So the last argument gives us a matrix, so from there we want its p attribute or its position vector. And then to test, we'll send our vehicle to that location. So vehicle.add control point target. Then what do we want to do? Let's transfer our part into the vehicle's container. So I'll say we have to create a delay first because we have to wait for our vehicle to get to the pickup location. So delay vehicle.total time. And then we'll tell our part to transfer itself into the container that we defined here in our script through its input port. So we'll give it index of 0. And after that's done, let's give our vehicle a new path. So I'll say vehicle.clearMove. And then where do we want our vehicle to go? Let's go back to where it was before. So I'll say position matrix equals component dot position matrix. And then we'll get the identity of that matrix. So I'll say position matrix PM to call the identity method. And then we'll tell our vehicle to go to the position vector of that position matrix. Okay, let's now compile the code. And what we expect to happen when we run the simulation is the vehicle will get the signal from the conveyor that a part is available to be picked up. The vehicle will get that part, and the part will then request from the conveyor what needs to be sent to the vehicle for it to go and pick it up. The vehicle will get that information, go to the pickup location, grab the part, and go back to where it was before. Let's run our simulation, and fingers crossed. Oh, there goes the vehicle. Yep, it picks up the part and it goes back. Great. So with this information, you could tell the vehicle to pick up any other component you want to by setting the transport protocol target information. You could also tell the vehicle what container something is in, or only pick parts from there. You could also tell the vehicle if something is available or not, and where you want the vehicle to go to pick up the parts. And if you're feeling funky, let's actually try to do that now. Let's add another conveyor to our layout. I'll go to the Home tab, and under the eCatalog panel, let's go to the Conveyors New Smart Collection under Models by Type, and add the first conveyor. And now what do we want to do? Well, we probably want to tell our vehicle to go to some location here in the conveyor to drop off the part it picks up here. So let's select the conveyor that we added. Now also add a transport protocol to this conveyor. I'll go to the Modeling tab. Let's first add a feature, and we'll rename the feature to be drop-off point or drop-off location. So there's the frame feature. Let's move it on the x-axis there. Now let's add a transport protocol behavior to our conveyor and a Python script. In our script, let's actually do what we did earlier. Get the component object. You could copy and paste the script from the template conveyor, but we can just quickly write it now. We'll get the path, so comp.getBehavior. In this component, the name of its path is path underscore underscore hide in capital letters underscore underscore. And then we'll get the frame. So frame equals comp.getFeature. Drop off location. We'll get our location, which is going to be the component's world position matrix times the frame's node position matrix. And from there we'll get the transport protocol, so TP equals comp.getBehavior. We're finding the behavior called transport protocol. Then we want to use the event, so tp.onTransportInfo. When you ask for some pickup location or drop-off point, let's call this function called order. So define order, call it caller. Then we want to use our transport protocol to set the target information. So set target info. And now we'll call VC available. Give the component, give the path, and our location. Compile the code. Let's exit out of this script. Let's now go back to our mobile robot script. And instead of going to the original location of our vehicle, let's delete these lines of code. And using the application object, we'll go create a variable called drop-off, or we could call it other conveyor equals app.findComponent. The name of the component we added was called conveyor. Let's now use our part to get new data. So data equals part dot get transport info. This time we want to request the information from the other conveyor. And then from there, we'll use our vehicle. Let's first get the target location, sorry. So target equals data. Could be -1 or 3 for the index. And then we'll tell our vehicle, remember the target has to be a position vector, sorry. So add that p attribute. We'll then do vehicle.addControlPoint target. And then we want to create a delay to wait for the vehicle to get to the drop-off point. So vehicle.totalTime. Then we'll use our part to transfer itself into the path of our other conveyor. Now, do we have to write lots of code for that? No, because remember, our other conveyor also gave the container it wants to use for the delivery, which is in our data list here, or tuple, or data variable, sorry. And that would be the third argument. Yeah, sorry. So there's 4 pieces of information in total you can get from the transport info. So we want to get the index of 2 for the third element. And the port we want to go to is the input port of the path. And let's see if this works. Compile the code, minimize the script, and what we expect to happen is the vehicle should go pick up the part like it did earlier, take the part here to the drop-off location, and the part should move along this conveyor. Run the simulation. Here comes the vehicle. Show me that magic. Oh, look at that! Oh, snap! It worked! So there you go. Great. So now you know how to get the pickup location for a part as well as the drop-off information.